class, and welcome to your next video on chemistry, life, and matter. So we've talked about what makes something alive. So now we're going to talk about the chemistry behind life and exactly what is in those chemicals and atoms and bonds. So first off, what we need to understand is what is matter. Matter is any substance that is composed of atoms or molecules. It's the basic unit that makes up all living things. It's living and non-living things has atoms. So the couch you're sitting on, the chair you're sitting in, the pencil you're using to write with, it's all made of matter. So matter is anything that has mass and takes up space. So pretty much anything surrounding you or next to you can be considered matter. Now, I just used this word atom, but what is an atom? An atom is a basic unit of a chemical element, and it cannot be broken down further than itself. An atom is very, very tiny. In a Times New Roman 12-point font period, there are over 3 million atoms. So there are lots and lots of atoms in our world today. So an atom is made of 3 subatomic particles. 2 of those particles, the protons and the neutrons, are contained in the center called the nucleus. The protons have a positive charge and the neutrons have no charge, or they have a neutral charge. So they have weight, and we use that weight to determine the atomic mass, but they have no charge. And the electrons have a negative charge. So overall, an atom generally is not charged. So if we look at this picture, this is a picture of a carbon atom. A carbon atom has 6 protons, 6 electrons, and 6 neutrons. It has an atomic mass of 12. Now, each proton and each neutron contributes to the atomic mass, but the electrons do not. The electrons are so small and move so quickly that they are negligible in the mass. But the neutrons and the protons stay pretty steady, and they have a bigger mass, so that we count them. Now, you see we have 6 positive charges and 6 negative charges. So overall, the atom is neutrally charged. Most atoms are neutrally charged. Now, each atom has what are called electron shells, and that if we look at this particular atom, we can see the first electron shell, where the first electrons are, has 2 electrons. Each shell after that will have 8. So if we look at the next slide, we're going to see that. Each atom has levels that the electrons must occupy. Those are the electron shells. In these shells, there's only so much room for our electrons. In that first shell, there's only enough room for 2 electrons. But every other shell holds 8 electrons. Now, the outermost shell, those electrons are given a special name, and I think you should write this down. The outermost shell, those electrons are given the name valence electrons, and these are really important electrons because of bonding. Now, the valence electrons want to have a full shell. So whether they're at the shell that only holds 2 or the shell that only holds 8, they really want to be full. So they're going to do whatever they can. They're going to give away electrons or gain electrons in order to have a full shell. So these are really going to come into play when we talk about different types of bonds. So elements. Elements are a pure substance made up of one type of atom. For example, we might have a hydrogen atom, we might have an oxygen atom, we might have a carbon atom. Right here, I want you to look at this picture. We are looking at several different things when we look at this picture. This is what you're looking at when you look at the periodic table. You're looking at the atomic name, the atomic symbol, the atomic number, and the atomic mass. So what are all those things? Well, first off, the atomic name is just the name of the element. The atomic symbol is what scientists use to abbreviate that element. Then we have the atomic number. The atomic number indicates how many protons the element must have to be considered that element. It also is how many electrons it has if it is a neutral element. Now, we also have atomic mass, and we measure that in atomic mass units. The atomic mass measures the protons plus the neutrons. Now, you see 83.80 here. We generally do not have 0.8 protons or 0.8 neutrons. We have one whole proton or one whole neutron. So the reason we have 0.8 here is we take an average. We take an average of everything that exists out in nature. And we have different types of each element that exist out in nature. So we have ions, we have isotopes, and we have stable ions, or stable atoms. So this one is a stable atom, but the average of the atomic mass here is going to be 83.80. So the different types of atoms, what I just alluded to, they can occur in different forms such as the stable atom, the ion, or the isotope. The stable atom is an atom that has no charge and its number of neutrons occurs in nature. So it's going to be, if it's carbon, if the atomic mass says that it's going to be 12, it's going to have 6 protons, 6 neutrons, and 6 electrons. It has no charge, and we're going to take that average and we're going to subtract the amount of protons from it, and that'll give us about what generally occurs in nature as far as the neutrons. Next, we have an ion. Atoms of the same element normally have the same number of electrons as protons, but when they don't, they are called an ion. This happens when we gain or lose an electron, and the number of protons cannot be gained or lost. Only the electrons can be gained or lost. That's something very important to remember. Now, based on this, this is based from our valence electrons. Remember how I said that we want a full shell, and some atoms are going to grab some and take some, and some are going to give some away so they have that full shell. This is where it comes into play with our atoms. If they're just a plain atom, but they have a charge because they've given away or they've taken some electrons, this is what they're called. They're called an ion. The last one that we talked about there was an isotope. So there are 2 atoms with the same number of protons but different number of neutrons are going to be called an isotope. So we have carbon-12, carbon-13, and carbon-14. What that means, they're all carbon, they all have the same number of protons and same number of electrons. We have no charge here, but they have different numbers of neutrons. So we are alluding to, that number there is alluding to the atomic weight. So carbon-12 has 6 protons and 6 neutrons. Carbon-13 has 6 protons and 7 neutrons. And carbon-14 has 6 protons and 8 neutrons. So we're never going to have any type of charge on these atoms, but we are going to have more and more neutrons within the nucleus of the atom. Lastly, let's talk about bonding. Bonding is what's going to create a molecule. A molecule is just multiple atoms together. So, compounds and elements form when the atoms bond together. And there are 2 different ways we want to know right now. The first one is the ionic bond. It's when one or more electrons are transferred from one atom to another. Your example right here is going to be sodium chloride. So what's going to happen here is your sodium's going to have an extra and your chlorine's going to need one. And what's going to happen is your chlorine's going to take it, and then they're going to bond together because they're both going to have a charge, and they're going to have opposite charges, and opposites are going to attract to each other. Now this bond is very weak, and it can be broken very easily. The next type of bond we have is a covalent bond, and a covalent bond is when one or more electrons are shared and they orbit the nuclei of all of the atoms. This is going to be a stronger bond, and we see this with water. We're going to share all of those electrons, so eventually all of the atoms in the molecule are going to have a full set on that outer shell, but it's not going to happen all the time because we're sharing those electrons. And since we're sharing those electrons, what's going to happen is we're going to create this bond. And this bond is going to be a stronger bond. It's going to be a lot harder to break than that ionic bond. So the difference between these two, ionic bond is when we're transferring those electrons. One's taking or one's giving. And the covalent bond is when one is actually sharing with another. We're sharing it throughout the entire molecule. Okay, so make sure you got all of this down. Make sure you got some of these figures down. They were really good figures to get into your notes. And we are going to talk about this in class. We will see you tomorrow.